Hello, in this video we're going to take a look at some exponent rules and review a little bit of those exponent rules and order of operations. So just a quick reminder about exponents. If you have a power times a power with the same base, like this rule here, number 1, power times a power with the same base, you can add those exponents. When you have a power minus or divided by a power, you're going to subtract the exponents, and a power raised to a power, you're going to multiply those exponents. So those are the three basic ones. Power times a power, you add. Power divided by a power, you subtract, top minus bottom. And a power raised to a power, you multiply. Now when you have a product that is raised to a power, remember that you can split that up and write it as the first one raised to the power times the second one raised to the power. But this only works if what you have on the inside of the parentheses here is either multiplied or divided. Then you can write each one raised to the power. If you have a plus or a minus because of order of operations, the plus and the minus put it down on a bottom level. You have to have either the product or the quotient raised to a power. You cannot distribute a power if there's a plus or a minus in there. If you have something raised to a negative power, like we have here on rule number 6, then what we're going to do is we're going to write that as the reciprocal raised to the positive version of the exponent, or the opposite sign of the exponent. If you have a base raised to a fractional power, another way of writing that is using our radical notation. So a to the m over n, whatever's in the denominator, is going to give you the index on your square root or your cube root or whatever it is, and then the number that is in the numerator on the exponent is what we're going to raise the whole thing to. All right, remember order of operations, parentheses are going to override everything else. And then the second level is any exponents, which does include radicals. As we see in 7, we can always write a radical as an exponent. So we're going to treat stuff like square roots and cube roots on that level. And then the third level is multiplication or division. We always work left to right when we're talking about multiplication and division. Anything that's on the same level, you work left to right. This does include distributing a negative. So if you have a negative in it that you're multiplying by, that is on the multiplication level. And then addition and subtraction is on the last level. So let's jump into a couple of examples. All right, the first one I want to look at is really just a comparison between negative 10 in parentheses squared versus a negative 10 squared. The difference on this is one has parentheses and one doesn't, and it's a big difference because here we want, on this first one, we have negative 10 in parentheses squared. We want to square that whole thing, so a negative times a negative is going to give us a positive, and then 10 squared is 100, so that one is going to be equal to 100. But because of order of operations, we can think of this parentheses as just around the 10 because the exponent is one level higher than multiplying by this negative out front. And so a negative 10 squared is going to be a negative times 10 squared, which is negative 100. All right, our next example, we have 3 to the negative 5th times 3 cubed. This one's just a basic rule. We can use that first rule that we went over at the beginning of the video, or we can write this as a quotient using rule number 6 there, and then use that second rule where we have a power divided by a power. I'm just going to stick with the first rule. So 3 to the negative 5th times 3 squared is going to be 3 times negative 5 plus 3. And when we simplify that exponent, we're going to get negative 5 plus 3 is a negative 2. And now we can use that sixth rule and write that as 1 over 3 squared. And simplifying that, we get 1/9. There's a couple of different paths that you can take, but they're all going to end up in the same place. All right, our next example, we have the square root of -12 in parentheses squared all underneath that square root. So just a little reminder here, the square root and the square are not going to directly cancel out. We always want to work inside out. And so inside, we've got a -12 squared. Well, that negative is on the inside, so it's squared. That's going to be 144. And then when we take the square root of 144, we get a +12. You might also see the square root of any number squared written as the absolute value of that number. So there's going to be some times throughout this course where we are going to simplify stuff that looks like that, and it's always going to be the positive version because it has to be a positive to be underneath that square root. All right, so now these last two examples here are just simplifying, kind of putting all the rules together. So -4 cubed, that negative is on the inside, so it's going to be cubed as well. If we have a negative raised to an odd power, that's going to be a negative. And then 4 cubed is equal to 64. Not a whole lot we can do with that x to the 6, so I'm just going to leave that for a minute. We have yz cubed, so that means we can split that up. That's multiplied together, so we can write it as y cubed times z cubed. And then in the denominator, we have 3 cubed. 3 cubed is 27. And then we can just simplify, or just write the rest of it. Nothing's going to simplify in the denominator. We're going to have an x squared, y to the 8th, and z. Now we have some powers. Everything's multiplied together, so if we have any common factors, we can divide them out. 64 and 27 do not have any common factors because 4 and 3 do not have any common factors. All right, so we're going to be left with -64 in the numerator and +27 in the denominator. Now for our x's, we have x to the 6th over x squared. If we divide those out, 2 of those x's are going to divide out, and we're going to be left with 4 in the numerator. That's the same thing we get if we do top minus bottom on our powers. On the y's, we have y cubed over y to the 8th. That one we're going to have 3 of them cancel out, and that's going to give us a y to the 5th in the denominator. If we were to use the rule, we're going to get 3 minus 8 is going to give us -5, and that means y to the 5th on the bottom. And then z cubed divided by z, one of those z's is going to divide out, leaving us with a z squared in the numerator. That is a positive power, so it's going to stay in the numerator. And that's as simple as we can get it. So that will be our simplified answer on that example. And this last one, we've got 2x to the -5th over 7y to the -4th. All of that fraction is raised to the -2. Now there's a couple of different paths that we can take on this one. I tend to like to simplify on the inside and then work my way out. So I'm going to go ahead and do that. So 2 is not raised to any power. It's going to stay in the numerator where it is, but that x to the -5th is going to become an x to the 5th on the bottom. In the denominator, the 7, again, not raised to any power, so it's going to stay right where it's at. Y to the -4th is going to mean y to the +4th on the opposite side of the fraction. Negative just means it's going to flip to the opposite side of the fraction. So it was on the bottom. It's going to move to the top as a y to the +4th. And then raising it all to the -2 power. So that negative out front is going to flip our fraction. And when we do that, we're going to get 7x to the 5th. It was on the bottom. It's going to move up to the top. And the 2y to the 4th is now going to be on the bottom. And that -2 is going to become a +2. And you can combine some of these steps if you would like to. And then our last one is going to be to square it. We are going to square each of our 4 factors here. So 7 squared is going to give us 49 on the top. X to the 5th squared, that is a power raised to a power, so we are going to multiply those exponents. 5 times 2 is 10, and then 2 squared is 4, and then y to the 4th squared is going to be y to the 8th, and that is as simple as we can get, and we are done. I will see you guys next time.